Welcome students, let us see one question of graph theory which is very conceptual and very important. So let's start. So question number 2, it is saying in an experiment on artificial intelligence, a robot is put in a maze which has 6 rooms labeled A to F. So there is a robot which is based on artificial intelligence, and it is put in a maze which has 6 rooms labeled A to F, as you can see here: A, B, C, D, E and F. Each of the rooms has gaps in the wall connecting it to the adjacent rooms. So each room has some gap which connects to adjacent room. For example, A has this gap. From this gap you can connect to B. This has a gap also which connects to E. So like this. So what's the question is saying? So the question is saying draw the maze as a graph. So we have to represent this situation, this maze, as a graph, while the vertices represents the different rooms, right? So first of all, vertices represents rooms. And how many rooms we have? We have total 6 rooms: A, B, C, D, E and F, right? And edge representing the gaps between the room. So edge represents the gap, or you can say gate, basically, which connects one room to another room. So let us see the next part. The robot moves randomly. So robot is moving randomly. Once in a room is equally likely to leave through any of the gap. So he can go in any room. Each room is equally probable, right? So we have to represent this situation graphically. So first of all, how many vertices we have? So we have total 6 vertices. So let's draw this situation. So let us suppose I have a vertex A. So from A he can go to B. See, from A he can goes to B. So I can write A to B. He can go A to E also. So he can go A to E also. From E he can connect to D. So from E he can connect to D, and from E he can connect to F also. So from E to F also. Then F to D, he may go from F to D. So F to D, we can write it F to D like this, F to D. And D to C, there is also a path D to C. There should be some vertex C. So let's suppose this is the vertex C. He can go to the vertex C also. See, I think I should not mark these arrow marking, because he can go from F to D also, D to F also. Robot is free to move in any direction, so I should not mark any arrow marking. So from D to C, he can go from D to B as well. So D to B, there is path also. So let me write its vertex outside of this diagram. So this is going to be vertex A. So I think A, B, all 6 vertices have been marked, and there is one gap also that connects C to B. So you may connect C to B. There is no arrow marking in this graph. Why? Because robot can go from F to E, E to F also, right? So this completes our first part, that is the part A. Let us see its second part, that is the part B. It is saying write down a transition matrix for this maze. So what's the transition matrix is? Basically, a transition matrix is, it is, see, first of all I should write all the vertices here: A, B, C, D, E and F. Similarly here also A, B, C, D, E, F, and make a table then we will going to understand how to write its transition matrix. First of all, the direction of transition matrix is opposite to the adjacency matrix, right? Let us see. So this is our diagram. So for example, see what the transition matrix is. uh, First of all, its direction is opposite to the adjacency matrix. So from here, in this case, we will see from column to row. I have to go from A to A. So there is no loop A to A, so its entry will be 0. Next, A to B, right? See, from A there are two edges, A to E, A to B, and each are equally probable, right? So from A to B, yes, from A to B I can go, so its probability is 1 by 2. A to C, no, no. The next one should be, see, in this complete scenario, A to E, yes, equal chance, so 1 by 2, and A to F, no. Next, C, from B to A, we have to see from column to row. B to A, B to A, see, B have three edges. From B we have three edges, each are equally probable, so its probability should be 1 by 3. So yes, its probability should be 1 by 3. B to B, no. B to B should be no. B to C, yes, 1 by 3. B to D, yes, 1 by 3. As you can see here, B to D, there is a path. B to D, B to E, no. B to F, no. Let me change the color. Next, C to A. Is there a C total two edges from C, so each are equally probable, so each probability has 1 by 2. So C to A, no. C to B, yes, 1 by 2. C to C, no. C to D, yes, 1 by 2. C to E, no. C to F, no. D, D to A, D to A, no. D to B, yes. C total from D we have 1 2 3 4 4 edges, so each has probability 1 by 4. So D to B, 1 by 4. D to C, 1 by 4. D to D, no. D to E, 1 by 4. D to F, 1 by 4. Next, E, from E to A, yes. See, E has total 3 edges, so each will have probability 1 by 3. So E to A, 1 by 3. E to B, no. E to C, no. E to D, yes, 1 by 3. E to E, no. E to F, yes, 1 by 3, right? Next, from F, F to A, no. No direct connection. F to B, no direct connection. F to C, no direct connection. F to D, yes, F has total 2 edges, so 1 by 2. F to E, yes, 1 by 2. And F to F, so that's the 0. So this is the transition matrix for this graph. This complete our part B. Let us see its next part. If the robot begins in room A, right? If the robot begins in room A, what is the probability it is again in room A after passing through 4 of the gaps? So it means if it has travel 4 edges, see, after travel 4 gaps means 4 edges. After traveling 4 edges, what is the probability that the robot will be again in room A? So for this, what we have to do, we have to find the, let us suppose this is a matrix A, right? We have to find A raised to power 4, right? Then we will see the coefficient, the entry of A, first row, first column, because I want starting position A and ending position A also. So let us see. So for this we will use our calculator. So first of all, how to use this calculator? First of all, go to your run matrix. So I'm going to run matrix, then go to your matrix F3. So we will define our matrix. So I'm clicking executing. So first of all I have to write the dimension. So its dimension is 6 by 6, so it's 6 by 6. Yes, so now I have to enter all the elements of our transition matrix which we have find earlier. So I am writing it quickly. So it is 0 1 by 3, 0 0 1 by 3, 0 1 by 2, 0 1 by 2, 1 by 4, 0 and 0. The next row 0 1 by 3, 0 1 by 4, then 0, then 0. The next row will have 0 1 by 3, 1 by 2, then 0, then 1 by 3, then 1 by 2. The next row will have 1 by 2, then 0, then 0, then 1 by 4, then 0, then 1 by 2. Then next row will have 0, then 0, then 0, then 1 by 4, then 1 by 3, then 0. So I have entered all the elements of our transition matrix. So what we have to do, go exit from this, then I have to find its power 4. So shift matrix, my matrix was A, so I can write A raised to power 4, so it's power 4, and then execute this. So this is the, see, A raised to power 4. So I have to find what's the probability that it will be again in room A. It means, see, this was the room A, the first column was room A, the first row was also A. So this is the probability. What's the probability? 0.2222. So our answer will be 0.2222, right? So its C part will have answer of, the answer of C part will be 0.2222, right? This is the answer of third part. Let us see its next part. We have to find the two rooms which are most likely to be visited by the robot. So we have to find two rooms which are most likely. So it should be high, it should be max, it should be little bit maximum as well as equal. Both should be equal. So why? Because two rooms which are most likely to be visited. So we need two, not maximum exactly. So what we have to do, we have to find the highest, we have to find the high power of our transition matrix. Let us see, then we will analyze the data. So first of all, exit from this. We have to go shift, then matrix, then our matrix A, then raised to power. Let us suppose I have put it 30 and execute. So as you can see, we have to find the two rooms which is most likely. So two rooms, see, we have to see this second row and fifth row. Second row and fifth row, as you can see, both have nearly equal probabilities. Second row, and I am talking about this second row and this fifth row, both have nearly equal probabilities. So these second and fifth row, that is the what means room B and E are equally likely to be visited. So our answer should be B and E. Let us see. So its answer should be B and E. And the last part, determine the percentage of time that the robot will be in each of these rooms. So see, this is the according to the matrix, we have the probabilities. So to get the percentage of time, it means percentage of probability, what we have to do, we have to simply multiply it by 100. So let us see what was the entry in our matrix. So it was 0.1874. So when we multiply, it will be 18.74. So it should be approximately 18.74%. So I think it completed our this question. So if you have liked this solution, please like this video, subscribe this channel for all related question related to your IB mathematics. Thank you. Thanks for watching.